Hey everybody, this is Vin. In this topology, today we are going to be talk about the STP and the whole thing and understanding about the STP, how it's work and what are the functionality, the concept about this. So here you can see this is the topology, and you might wondering about this number, what it is, and below this MAC addresses. Okay, so the STP that we call is spanning tree protocol, which is working on the basis of IEEE standard, which is 802.1d for this, okay, for spanning tree protocol. And this is the kind of loop prevention protocol, and it's a Cisco proprietary protocol. If it's not exist in a topology, so we can face the probably the all possible problems that we can face, like the broadcast storm, MAC address instability, and network outage, this kind of thing, so what about this all concept behind it and how it's actually work, that we are going to discuss over here. Okay, so the term that we call the root bridge, what it is and how it's elect. So as you can see right here, these are all the numbers that we call the bridge IDs, and this is the combination of this priority number and this MAC address number. On the basis of this, the bridge ID, the devices, the switches which consider, and initially they assume itself as a root bridge until the election, and once the election done, on the basis of the lowest bridge ID, that will make sense for it, and that will make itself as a root bridge, and all other switches will act like a non-root bridge. Okay, so how to actually consider about that? Okay, so the switches send each other to the STP messages to understand the things like who have the lowest bridge ID. Okay, so in that way they send messages every 2 seconds to each other, right? And once it's done, so they elect the lowest root bridge, or on the basis of the root ID. Okay, so as you can see, which is a common thing, that is a priority ID, and then after we have to go for the MAC address table, MAC address comparison. Okay, if in case if it's die, okay, if it's similar to on each and every, so we have to then compare with the MAC addresses. Yeah, this is all about this, and once it's done, then after we have to proceed for the root port. Okay, so before that we have to understand about this all D, which is a designated port. Okay, so the all ports which is over the root port. Okay, sorry for that, that's a this is not for the root port, this is only for the root bridge exactly. So that we will going to be discuss about further, not now, about the root port, but this is the our focus right here is on over the root bridge right here. So this is D, that is a designated port. So each and every port on the root bridge, which is always going to be the forwarded port or designated port. Okay, and the devices which is connected to it, next to it, okay, which is next to it, like these switches, that will going to be a root port for each and every switch have a one single root port. And how it's considered about that, so you will going to always see a root bridge, the neighbor devices have its port which is connected to the next to the root bridge, they always, it's going to be the root port. And why it is, because if I will call the term that we call the root port cost or the root cost. Okay, so this is the kind of numbers that we decide on the basis of the interfaces speed, on the basis of the interfaces, like if I have 100 MB PS speed or 100 MB, like this is the F01, right? So there's a 100 MB is speed right here, so on this interface. So on the basis of that, the cost would be 19. Okay, as if I have the 1 Gbps 1 GB for this like the gigabit Ethernet interfaces. So I have to go with the on the basis of that all information I'm talking about. Now that is for 4, right? If in case we have 10 GB, okay, so 10 Gbps on any interface, so for that we have to consider with the cost would be 2, okay. And if in case we have in a large number, like we have 100 the cost, so in that case that 10 MB that would be the SP. This is the table that we have to understand. This will make our mind for these numbers, and that will be verbally we have to consider about this all the calculations, right? So yeah, right here, if this switch will going to be our considering about the root port, so it can go with this way to connect to the root bridge, and it can go to this way. So if there is a 19, the cost is 19 right here from this interface, and from this is also a same interface with the F02, so it is 100 for this 19, 19, 19, 19. So if I were to go this way for the election, and okay, for this way the election would be easier, right? We have to go this way, and this way, so there's 19, 19, 19. Okay, so that would be the cost, that the cost would be high for this. And if I will go for this way, the neighbor which is next to it, with the near to it, so we have to go the lowest cost. Okay, we have to go with the lowest cost. For that reason, this would be always for this would be nearest and lowest cost. For this switch, it would be a nearest and lowest cost. So we have to consider about this way, right? Okay, what about this interfaces? So what I'm going to make it over here, it is okay, so we have to just make the things in a right way for this. So because of that, I'm putting right here the value. Okay, so remember that for these interfaces I will going to make it the both, not one single will going to be sound to be different, and that's correction that we are going to be make it over here, that would be different. But the root bridge and what we call non-root bridge, okay, yeah, that the remaining configuration that we consider as a non-root bridge. Okay, before that we have to just think about this all, and then we have to proceed for that, right? Okay, so for this the one should be work for the connectivity, and one should be block. So we have to just give it R, which is a root port for this. And so how we can consider about which port would be a root port. So there's a two interfaces which is connected to two. As we know, the 19 would be cost for this, right? That 19 would be cost for this, but there's two interfaces which we have to consider for this. That is the main point right here. So we have to put it right here for this at a moment, and we have to think and consider about this point, what would be that. Okay, so as you can see, in this situation, when there's a two interfaces, it means that there's a redundant link. So it means that that's a cost which is going to be tight for this moment, and which is thinking like the things in a right way. But we have to the whole concentration which is going to be based on next device and their interfaces, the cost of that. Okay, so if in case there is a F02 and F03, okay, so if I will look at this, the cost of this, okay, which is you can see right here, the F02 and F03. So F01 is right, 2 is there, and 3 is here. Okay, the cost of this, it's high, and 2 is lowest. So we have to go with the lowest one. Okay, so the lowest one would be good for this. So the lowest is a 2, so we have to make the redundant link to this one. Okay, is F01. Okay, okay, now, and in the same way we have to consider for this interface too. And for this if it is a bridge, a root bridge, let me just make it like, okay, it would be a big problem for us. Okay, now thereafter we can do that I want. Okay, so at this moment this road bridge is which is a road bridge in real. I just want to show you, like, it's very easy to identify right now. Okay, so yeah, for this interface, which is in the same situation, is 19, the cost is right here, which is near to it. So we have to make a decision which interface is going to be the root port for this, right? Because the things is that the interface is going to be tie at this moment, right? The because the both are given over here. So in the situation, if we are stuck in this situation, if in this situation we have to consider about the next to the device, and in that device which interface have the lowest cost. Okay, so if I will think the 101 F01 and F04, so I will just go for the F01 and F04. So one is right here, so I will go for the one, and its interface connected next to it the one. So the redundant link would be F01 for this. Okay, yeah, you get it what I try to say. It means the redundant link would be based on the next to the device. So the next to the device, it is the which is right here, the switch one, and the interfaces which is connected to it, we have to select the neighbor's device the port cost. Okay, neighbor device port cost, the which is the minimum. So that would be the redundant link for this. This is the thing about this. Okay, so now we're done with it. Okay, now this is the time to elect this is time to make the link with this device. What about this, where it is? Okay, we have to make it again. This, I think unknowingly we did it like, okay, so again we have to just make this thing. I forget which one was the root port over here. So again I will, this is the device, and next to the device, the neighbor device is this, and in this the neighbor's interface cost I have to consider. So I will go into it and check the F01 and F03. Okay, F01 and F03, so F02 and F03, sorry for that, 2 and 3. So the minimum would be 2 in this situation, so 2 is here. So the F01 would be the redundant link for this. Okay, sorry for that, not redundant link, the root port. This is, it would be the root port. So I will give it R to it. Okay, now it's there. Now on this switch there's one single redundant link that should be, and that is, okay, for each and every switch there's one single redundant link. Okay, we have to make this redundant link to this device too. Okay, so what we have to do for this is, okay, so we have to call the same situation. We have to make the things like, we have to consider the cost for this. So the cost would be similar. In this situation the cost would be same. So if the cost is same, what we can do next is the next which device next to it. Okay, so MAC address would be good idea, you know, in this situation. Okay, so because if it is like this is the situation for this switch 4, it is in between the two switches and the cost are time. Okay, but it's in between these switches. So in this scenario we have to make comparison about these devices, the bridge IDs. Okay, so which is the first IDs which is going to be tied right here, the second. So okay, so this is the big one for this, right? This, it would be the big one. So I have to go with the lowest one, which is here. So for this interface, I will make this interface as a written as a root port, sorry, as a root port. I will configure this as a root port. Okay, so apart from this all, which is remaining, okay, that all are going to be non, okay, these all are going to be blocking state, not forwarding, blocking state. Okay, this also is going to be blocking state. This interface also going to be blocking state, because it's directly connected to the switch, and it's also directly connected to the switch, so it's going to be blocking state. Okay, this is all other thing that I want to mention over here. This is all set. Okay, this is all about this, and we can check this thing, you know, if I will go in this way, like the timing, the cost is 38. The cost is 38. It is okay. So yeah, this kind of information that we can get it from this.